Rahim. Assalamu alaikum. This is Jahangir Sumro, Assistant Professor, Electrical Engineering Department, Sakraib University. We have completed 4 lessons of LabVIEW Core 1 training. Please make sure that you have completed all 4 lessons before watching this lesson 5 part 1. Alright, in this lesson 5 we are going to learn about arrays, clusters and type definitions and be able to identify applications where using these data structures can be beneficial. Topics covered will be arrays, common array functions, polymorphism, auto-indexing, clusters, type definitions. Moreover, in this lesson, there will be 3 exercises: exercise 5.1, exercise 5.2, exercise 5.3. This is perhaps the biggest lesson of LabVIEW Core 1 training in terms of length. Alright, so arrays are very familiar concept in every programming language. So the objective is to identify when to use arrays and learn how to create and initialize arrays. 1D and 2D arrays, creating an array control and constant initializing arrays will be learned. Alright. So array is basically collection of data elements that are of the same type. So this is the main definition of your arrays, that arrays consist of collection of data elements of the same data type. It is not possible that array can consist of multiple different data types. No, it's not possible. Array always consists of data elements of the same data type. Okay, what are the elements of arrays? The data that make up the array are called elements. Elements can be numeric, boolean, path, string, waveform, and cluster data types. Third thing, that what is the dimension of array? Basically, dimension is length, height, or depth of the array. Arrays can have 1 or more dimensions and as many as 2 power 31 minus 1 dimensions. Please note a very important point, that array indexes in LabVIEW are 0 based. The index of the first element in the array, regardless of its dimension, is 0. So I again repeat that this is a very important point, that arrays are basically 0 indexed. The first element in array is array 0. This is 0 indexing. 100 element, this 100 number is basically 0 indexed. This is array 0. This is not array 1. Alright. And here, how many elements are there in array? 1, 2, 3, 4, 5, 6. 6 elements of this array are there. And this is 0 index, this is first index, 2, array 3, array 4, array 5. So it starts from 0 indexing. I hope this point is clear. Alright. As discussed, arrays can have multiple dimensions. This is basically a 1D array, 1 row of 10 elements, index starts from 0 indexing. These are the index number. See, indexing starts from 0 up to 9. Overall, there are 10 elements. For example, LabVIEW represents a text array that lists the 12 months of year as 1D array of strings with 12 elements. Index is 0 based, which means the range is 0 to n minus 1, where n is the number of elements in the array. So I again repeat, for example, if there are 12 months, so n will be 12 for the 12 months of the year. So the index ranges from 0 to 11. So this will be from 0 to 11 index numbers, index range in order to represent the 12 months of an year. Say suppose March is the third month. So it has an index of 2 because array starts from 0 indexing. Alright. Array can be 2D array. For example, this is a 5 row by 7 column tables of 35 elements. This is basically a 2D array. A 2D array is analogous to represent a spreadsheet or table. For example, if your data contains temperature readings and time stamps, one column is the time values and other column is readings. So this is basically a 2D array. For example, another example, LabVIEW represents a table of data with rows and columns as 2D arrays. Alright. So basically this is a 2D array. A 2D array stores elements in a grid. It requires a column index and a row index to locate an element, both of which are 0 based. So both of the elements are basically 0 based. So this is basically a 2D array. Alright. Array can be initialized or array can be uninitialized. An uninitialized array contains a fixed number of dimensions but no elements. Like you see here, this is uninitialized array because it contains a fixed number of dimensions but no elements. Whereas this is initialized array, and an initialized array defines the number of elements in each dimension and the contents of each element. So this is an initialized array and this is initialized array, and it is basically consisting of 2 rows and 3 columns. So it is a 2 by 3 matrix. Alright. So let us demonstrate how to create arrays in LabVIEW. Alright. Open a new VI, go to array and pick up array. So this is array. Now array is what? Array is the collection of elements of same data type. So you need to define that what is the data type of this array, because collection of data elements that are the same type makes an array. So you should define that what is the data type of this array. Go to numeric and select numeric control silver. So this is now an array of numeric control floating point DVA. Now say suppose I drag it here. Now basically this is a 1D array, and this is uninitialized array at this time. So this is 0 indexing, first 2 3 4 5. Let us initialize this array. Now this is initialized array and these are the elements of array, and this array consists of how many elements? 1 2 3 4 5 6 elements. There are 6 elements. This is 0 index, first index, third index, fourth index, fifth index, and sixth index. Alright. So see, first zero index, first, second, third, fourth, fifth, and this is sixth. Sorry, this is fifth because it starts from 0. This is 0, 1, 2, 3, 4, 5, and this is basically fifth indexing. Fifth means sixth element because it starts from 0, array 0. Alright. So you can search if the array is big, even you can search from here. Let us say if you want to see fifth indexing, click here, it will show you the sixth element, which is basically index number 5. Alright. Or if you want to search elements, you can also go to visible item and activate this vertical scroll bar. Let us make this array a little big, and then you can search the element if you want using this vertical scroll bar. See, you can search in this way. Alright. This is array of numeric control. How to array of numeric indicator? Simply you can right click it and change to indicator. Now this will become an array of numeric indicator. This option is also available. Alright, let me make it again. Let us again change it to control. Alright. Okay. So this is an array of numeric control. Alright, let us remove this vertical scroll bar now. Let us make another array of numerical vertical point silver. First pick up the array from here. Now let's make it vertical fill slide array. Alright. Let us make another array, and let's say this array is of Boolean switch. Let us make another array, and let us make this array of Boolean indicator. Array. Even you can change the size of this LED or any other of these different numerical different controls and indicators. Alright. So this is basically array of control, and you cannot connect two controls. You cannot wire array of control to another array of control. So let's convert it to numeric indicator. Change to indicator, and let's wire it. This is array of Boolean controls, and this is array of Boolean indicator. Therefore, this can be connected. Now that the purpose is that data will be transferred from this array, and it will be indicated on this array. Similarly, data will be transferred from this Boolean control, and it will be indicated on this Boolean indicator. From Boolean control to Boolean indicator. Let us see. Let's make it 8, 6, 4, or any other number you can make it. 3. Alright, 4. Alright. Let's see only 1, 2, 3, 4, 5 elements. 1, 2, 3, 4, 5 elements. Alright. And 4 elements. Let us turn on this one and this push button, and let's run it. You see, the respective value can be seen on the array indicators. Alright. Okay. So far, we have created a 1D array. So far, we have created a 1D array. We can also make two-dimensional array. For this, one way is either to drag it like this and then take it here. This is now 2D array. And if I make this element, let us mention this 5. Now this is basically a 2D array having how many rows? 1, 2, 3, 4, 5 rows. 1, 2, 3, 4, 5, 6 columns. 5 by 6 matrix. So this is a 2D array of 5 by 6 matrix. Alright. So you can create two-dimensional array consisting of multiple rows and multiple columns. Okay. This is 1D array. Another way to create 2D array is right click and go to a dimension. And then drag it as per your need. Alright. So we learned how to create a 2D array, how to create a 1D array of different data types. Alright, now let us discuss how to create array constant. Okay, we can create array constant using block diagram. For this, go to array and pick up the array constant and then mention the data type of this array constant. Let us make for now array constant of numeric constants. Enter it. This is a 1D array of numeric constants. You can mention the value of constants here. You can initialize this array, and also you can similarly make 2D array from it. Right click and create a dimension and then drag it. Now this is a 2D array of how many rows? 1, 2, 3, 4 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 columns. Alright. Okay. So we demonstrated how can we view the array, how can we create 1D array, 2D array of different data types. Alright. After this, now we will discuss common array functions. Alright. So in common array functions, we are going to discuss create and manipulate arrays using built-in array functions. Okay. So we will use LabVIEW built-in array functions to create and manipulate array. Let us refer to multimedia file.
After completing this module, Common Array Functions, you will be able to use LabVIEW's built-in array functions to create and manipulate arrays. LabVIEW groups functions you can use to manipulate arrays on the Array palette. Let's discuss some of the common array functions.
This multimedia file will discuss most common array functions used in LabVIEW.
The array size function returns the number of elements in the array. For example, if you have a one-dimensional array of temperature data and need to know how many samples of data are in the array, you wire the temperature array to the array size function. When you run this VI, the indicator shows 10. There are 10 elements in the array. For a multidimensional array of temperature values, the array size function outputs the size of each dimension. In this example, the 2D temperature array will output an array size of 2 dimensions. The first element equals 2 for 2 rows, and the second element equals 10 for 10 columns.
Alright, so now we must be clear that array size basically returns the number of elements in the array. Let us try the same thing in LabVIEW. Let me demonstrate. So we create a new file. Let us pick a array constant and make the array constant of DVL numeric constant, and let's drag it up to 10 elements. Say suppose 5, 4, enter any 10 elements of your own choice, initialize this array. 3, 2, 7, 6, 8, 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. So these are 10 elements right now. Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so now if you are using array size function, this will return the number of elements in the array. For this, go to array function, pick up the array size, connect it to the output of this array, and create an indicator here, and this should show you 10 elements. This is the size of the array. Alright, if you are creating a 2D array, let us create a 2D array from here. Let's copy it and let's add dimension here. Okay, and let's make it 2 and let's make it 6, 5. This is now a 2D array, and again you can check also size of array size of this. It will return array size of 2 rows and 10 columns, 2 by 10 matrix. Create indicator here. Create enter. This, you see, this is 2 by 10 matrix. The size is 2 rows and 10 columns. Alright. So this is the function of array size. That it returns the number of elements in the array. Okay, what is array size? Alright. So here the array size is 1, 2, 3, 4 elements, and this is 2 rows and 3 columns. So 4 and first 1D arrays are 4 elements, and this is 2 by 3. So this is the right answer. Submit. This is correct.
The array subset function returns a portion of an array starting at an index you define, and it contains the number of elements you define as the length. In the temperature data example, let's say you want to use the data for the 4th and 5th elements. Remember that arrays are always 0 indexed. So you wire the index value of 3, which is the 4th element in the array. Then you enter the length as 2, which will include the 4th and 5th elements. The result is that we get a subarray of 2 elements.
So let us use this array subset function in LabVIEW. Say suppose I am interested to find subset of this array. Go to array, and from here pick up this array subset, create its output to this array subset. So what is the function of array subset? It basically returns the portion of an array starting at an index you define and contains the number of elements you define as length. So let us say you want to see 4th and 5th elements. So if you want to see 4th, from 4th element, index should be 3 because array is 0 index. 3. And say suppose you want to see 2 elements, 4th and 5th, so create constant and 2 elements. This should give you 4th and 5th elements, which is basically 9 and 5. Create indicator to see that whether you are getting the right answer. 9 and 5. Hit the run button. You see you 9 and 5, you see. This is a function of array subset function. Alright. So if the index starts from 1, this is 1. So length is 3, 3 to 5. So subarray will be 3 to 5. This one. This is right answer. Alright, let's move ahead.
The buildArray function concatenates elements together into one array, or concatenates multiple arrays together into arrays of higher dimension. Let's say you need to add more measurements to a single channel in the temperature array data. You can wire a single scalar element into the buildArray function, and it automatically concatenates the new measurement to the temperature array. The buildArray function is a resizable node. It can be resized to add additional input terminals. If you want to add another channel of temperature measurements to the 1D array, You right-click on the output of the buildArray function to disable concatenated inputs. Then, when you create a 2D array, each channel is a separate dimension.
Alright, let's make it very simple. Now we are discussing build array. Basically, let's try this build array in LabVIEW. So, alright. So, build array, for this build array, I take this array here from here, alright, and I take any one element. Let's say this is the element, and I pick the function of build array from here. Now say suppose this is the data coming from the temperature, and you want to add one more data in this data set of temperature, so you can use the build array for this function. Just you connect this with this build array input. Now what will happen, this will basically concatenate this input into this array. What do you mean by concatenate? Concatenate means link things together in a chain or series. So simply the build array function concatenate elements together into one array. So this will be one array, and now elements will be 11. Now the size of this will become 11 after you use this build array function, and this element will be added into this array. This will be linked together in a chain or series of this array. This is called concatenation. Let's create indicator to see the output. Now you see 8. After 8 you will get another element that is also 8, and it will be shown over at this indicator. Let's run it. You see, now this is the 8 that is concatenated using this build array. Alright, so you can also check its array size now. Now this will be having array size of 11 elements, because 10 elements of this array and one element this is also added in series to this array. So it should show us how many elements. Array size should be now 11 here. See, it is 11. Alright. Similarly, you can use build array with two different arrays. So what will happen? It will concatenate multiple arrays together into array of higher dimension. How? See, disable concatenate inputs. Now you see it is disabled. Then create 2D array. Each channel is separate dimension. Now create indicator here. Now you will see this will be a separate array and this will be separate array, and these two arrays will be concatenated together. This will make a 2D array. Now here at the output you will see, sorry, concatenated is disabled, so this will not concatenate, but this will become array of higher dimension. So simply concatenate multiple arrays together into array of higher dimension. 1D array this and 1D array this. Then this will become at the output now a 2D array. So the result will be the array of higher dimensions. One here. You see, this is now a 2D array and result of this build array function. Alright. Okay, if you use this build array, and then what will happen? Certainly this build array function will concatenate multiple array together into array of higher dimension 732. and then 840. 732 and 840. Alright.
The index array function returns the element or subarray from an array at an index that you define. In the temperature example, you can use the index array function to extract an element at a particular index. For example, if you wire the constant 6 to the index input, you get the element at that index position. Similarly, we can extract entire rows or columns in multidimensional arrays. When you wire an array to this function, the function resizes automatically to display index inputs for each dimension in the array.
Alright, I hope this is clear. Let us try this thing in LabVIEW. Okay. I copy this same array here and I go to array function and I select index array. Now, what is the function of index array? It basically returns the element or subarray from an array at index you define. Say suppose I define index number 5. This means that it will now return element number 6 because index 5 means 6th element because array is a 0 index. So what is the 6th number element? 1, 2, 3, 4, 5, 6. This is 3 in our case. So create indicator and see output. It's returning 3. This is a function of index array. Say suppose you are using index array here in this 2D array. In this 2D array, alright, right click and create indicator and you define index row first row. So this will return you the first row. So it will return you subarray from an array, which is subarray is basically first row. First row is this 2 0 0 0 0 0 0 0 0 and then 5. See here, it should return you this subarray from the main array. Alright. See, this is the output. This is a function of this index array function. Alright. So row index is 1. So what should be the output in this case? It should show us 5 1 4 because this is row number 1. It will return first row. This will be the extracted row 5 1 4. This is correct answer.
You've completed this module. Here is a summary of what you've learned.
So in this multimedia, you completed 4 common array functions. One is the array size, return the number of elements in the array. The other is the array subset, returns a portion of an array defined by the index and length you define. And then build array, it concatenates elements together into one array or concatenate multiple arrays together into arrays of higher dimension. And the finally index array, this basically returns the element or subarray from an array at an index that you define. Thank you very much for watching part 1 of lesson 5. We will continue part 2 of lesson 5 in our next video. Thank you.